Hi students, today we are going to see about a chapter 9 rational number. A rational number is defined as a number that can be expressed in the form p by q where p and q are integer and q not equal to 0. So it is represented in the form of a fraction. It contains numerator and denominator with any integers. We can give any integers. So we can write 4 by 5, 2 by 1. 2 by 1 is a representation of a 2. So any number we can represent in the rational number. Even 0 we can represent in the rational number as a 0 by 1. So all the natural number, all the whole numbers, all the integer we can represent in terms of rational number. And note these points. Rational number includes integer and fractions. Next, the both numerator and denominator of these numbers are positive integers such a rational number called positive rational number. If both numerator and denominators are positive, this rational number is a positive. Numerator is a negative integer and denominator is a positive integer. Such a rational number called negative rational number. If the numerator is negative but denominator is a positive, we call that rational number as a negative rational number. Here we go for the exercise problem. So here we go for the exercise problem. List 5 rational number between -1 and 0. So first let me represent this -1, 0 in the p by q form. So it will be in the form -1 by 1 and 0 by 1. Right? Now the denominator are same. So let me see how many numbers are in between the numerator. -1 and 0. There is a no number, but we need a 5 rational number. So let me change to an equivalent rational number by multiplying 6 on both the numerator and denominator of both the rational number. So we will get 1 by 1 into 6 by 6 and 0 by 1 into 6 by 6. So we will be getting a -1 into 6 as a -6 by 6 and here 0 by 6. So now we will be having a numerator -5, -4, -3, -2, -1 and 0, right? So those we can choose that 5 rational number in between that. So therefore we will be getting as a -5 by 6, -4 by 6, -3 by 6, -2 by 6 and -1 by 6. Totally we need 5, so we got it as a 5, right? So even if we can simplify and write these 3 terms, otherwise we can leave it as these are the 5 rational numbers in between the given number. Numbers between -1 and 0. So here we go for the second one. Next one. So this also we want to represent a 5 rational number in between this. So denominator is not same. We have to make it same. Just by cross multiplying we can take as how we will do the LCM and we will add up for a fraction the same. So let me multiply 3 here, -1 by 2 into 3 by 3 and the 2 we will multiply here. So 2 by 3 into 2 by 2. So now the denominator will become same. It will become -3 by 6 and so 4 by 3 to 6. So in between we have a -2, -1, 0, 1, 2, 3. So 6 numbers are there. We need only 5. We can choose any 5. So therefore 5 rational numbers between -1 by 2 and 2 by 3 are, here is a -3, let us start with -2, -2 by 6, -1 by 6, 0, we can say 0 by 6, let me write it as a 0, 1 by 6, 2 by 6, right? The 5 we need, any 5, even you can add that, it will become 6, so we can remove one more. Clear? So here we go for the next one. Give 4 rational number equivalent to 2 by 7. So equivalent, so we can multiply any non-zero number to both numerator and denominator, we will be getting in a equivalent rational number, right? So except 0 we can multiply everything. First let me multiply with 2, we will be getting a 4 by 14, right? This is a 1. So let me try with the 3, 2 by 7 into 3 by 3. So 3 2s are 6, 7 3s are 21. This is the second one. Any number you can multiple. 2 by 7 into 4 by 4, we will getting it as an 8 divided by 28. We can multiple even 10, 100, thousands, whatever, whichever we feel easy, we can multiple. 20 by 70. So 4 by 14, 6 by 21, 8 by 28, 20 by 70 are the required for equivalent rational number. Draw the number line and represent the following rational number on it. So 3 by 4, we have to represent it. This number line is as usual how we will do for the fractions. Let me draw a number line here first. So I have drawn a number line here. Let me start with a negative 1. We have no negative, so let me put a negative 1. We don't want to go beyond it. 0, 1, 2, 3, 4, right? And you have to see the denominator is the 4. So we have to cut this into 4 equal parts, right? So each unit we have to cut into the 4 equal parts. That means they will be having a 3 parts, right? Same here also 3. Here also 3, right? And this one we will be calling it as a 1 by 4. This is 2 by 4. This is 3 by 4. And the 1 we will call it as a 4 by 4, right? 4 by 4 is a 1. So what we have to represent here, we have to represent the 3 by 4. So this part is what we have to represent. This part is what we have to represent it as a 3 by 4. Clear? As usual, like in a fraction number line, with the denominator we have to cut that each unit. And while drawing, make sure that each unit are in the equal length. So here we go for the next problem. Which of the following pairs represent the same rational number? The first pair is given as a minus 7 by 21 and 3 by 9. So we can compare the two numbers only if it is simplified number. The fractions we will compare by the simplified fraction, right? The same, this rational number also we have to simplify. So minus 7 by 21, if we simplify 7 table, we will get 1 by 3, right? What about 3 by 9? So 3 by 9, the 3 tables the common, so we will get it as a 1 by 3. But this is a negative 1 by 3 and this is the positive 1 by 3. Since both are not same, right? Here we go for the next problem. Here it's already simplified. Whether it is both are same? No. Since 1 by 3 is not is equal to 1 by 9, it is not a same. So the questions they ask, which of the pairs are same? So both the pairs are not same. If it is the same, you have to write it as equal. Here we go for the next problem. Fill in the boxes with the correct symbol, greater than, less than and equal to. So given fractions, so given rational number we have to compare. So as usual we have to compare by if the denominator is same. If it is not same, we have to change to denominator same. So by LCM we can take that 7 3s are the LCM. The 3 we can multiply with this number and 7 we can multiply with this number. So we will be getting a 5 by 7 into 3 by 3 and 2 by 3 into 7 by 7. So we will be obtaining it as an by 3s are 15 divided by 7 3s are 20. And this box, don't fill the box, at last we can fill. And here 7 2s are 14 divided by 7 3s are 21. Now your denominator becomes the same. So let we choose the numerator which is greater. So here the 15 is the greater, the numerator. So this will be the greater and this is smaller. So finally we have represent to the questions. The question is 5 by 7 is greater than 2 by 3. Clear? So make denominator same and then compare the numerator and you can do. And here we go for the next problem. It's very easy. We no need to change any numerator denominator since it is a 0 and it is some positive number. So always the positive number will be the greater. So like that, if they give the both negative numbers also, so one negative number, one positive numbers, we can say that the positive will be the greater. So here we go for the next problem. Which is greater in each of the following? So 2 by 3 and 5 by 2 is given. We have to say which is greater. The same as usual. Greater, we have to put a greater sign, right? So let me put a box as usual, the previous sum. So we have to put a greater sign. So here the denominator are not same. So let me make by cross multiplying 2 multiply with this number and 3 multiply with this number. So we'll be getting a 2 by 3 into 2 by 2 multiplied with, and the 5 by 2 is multiplied with 3 by 3. Now we will get, so numerator 2 is 4 divided by 3 2 is 6, and numerator 5 is 15 divided by denominator 3 2 is 6. So denominator is same. Now we can compare the numerator, which is greater, 15 is the greater. Then show the 5 by 2 is the greater and 2 by 3 is the lesser. So 2 by 3 is less than 5 by 2. The question is asking which is the greater. So we have to write, therefore 5 by 2 is greater than 2 by 3. Clear? So the next problem, write the following rational number in ascending order. So this number we have to write it in the ascending order. For ascending order also we should know which is the greater and which is the lesser, then only we can write it ascending order, right? So for that purpose also we need to change the denominator into the same. So you have to take an LCM. Here the 9 is an LCM, since the 9 is multiples of 3, and that's so let me multiple 3 for this number, first number, and second number we no need because we already have 9, that's the LCM, and 4 by 3 we can multiply with the 3. So we'll get a minus 3 by 3, sorry 3 is a 9, minus 3 by 9, and here the 2 by 9, and next here 4 3s are 12 by 3 is 9. So now we have to arrange it in the ascending order. So lower number to the greater number, right? So denominator are the same. Actually it is already in the ascending order, right? So minus 3 by 9 is the smaller, and the next 2 by 9 is the greater, and the 12 by 9 is the greatest in the given order. So we have arranged it in the ascending order. Clear? Thank you.